So welcome to Accessors and Memory Layout. In this video, we'll talk about how the arrow, dot and colon accessor operators work. We'll be introducing virtual memory, introducing permanent storage, stack and heap. Heap is also known as the free store. And how accessor operators relate to memory to bring it all together. And finally, we will bind another input action. By the end of it, it's pretty simple. We will get grabbed and release coming up on here, and we'll have a much better idea of why in the code we access methods like this, exactly what the ampersand and the colon are doing. So, see you in there. So, welcome back. We've managed to get our grab key working. What I want to do here is talk a little bit more about the syntax right here, where we specify the function that needs to be called. So there's a couple of things here that we want to talk about in more detail. One is the ampersand, although we have already covered this. This is an address of operator. All right, and this bind action method just needs to know the address it needs to go to find the function. But what do I mean by that? Well, you'll see in a minute on the next slide. I'm going to start talking about how memory is allocated and how these accessors work. You've also got another thing I want to clarify, which is once and for all, let's talk about when we use a colon, when we use an arrow, and when we use a dot. So this should bring it all together. Let's take a look. Accessors and memory layout. So imagine the white block is a block of memory on your computer. Strictly virtual memory. The operating system worries about whether this stuff is in RAM or is on the hard drive, or could possibly even be in the cloud in a future operating system. But it's virtual memory. So we are allocated a lump of memory for our program. And that can change. You can request more, but it's there. It's a white block. All right. But it turns out that the memory is split basically into two. This is a massive oversimplification. But you have permanent storage, the blue stuff at the bottom, and this is where stuff that we know at compile time gets stored. Things like functions themselves, or const expression if we use that. Any data that's unchanging can get stored in the permanent store in memory. The top half of the memory is the stack and the free store, or otherwise known as heap. And those two things can vary. They may start small and grow, and one may grow down in memory, one may grow up from the bottom. We don't need to concern ourselves too much about the details of the difference between stack and free store at the moment, or about exactly how they grow and shrink. I just want to explain that there's a part of memory that's kind of permanent and is laid out at compile time, and there is a part of memory that varies at runtime depending on what's going on. Okay. Now, this ties into the accessor operators. So, I've got a table for you. Three columns. The left-hand term is talking about, say I take ugrabber, colon, grab, or eword status, or std. That's what I mean by the left-hand term. So, if the left-hand term is a class, an enum, a namespace, or other things, but we'll just leave it at that for now, then the accessor operator you want is a colon. In the example of ugrabber, colon, grab. So, here we go. Ugrabber, colon, grab. It is known at compile time what the location of this is. This function is going to be put into the permanent store, and it's going to stay there throughout the running of the program. So ugrabber, colon, grab is a fully qualified function name, and then you have the ampersand, which is the address of operator, which tells this whole method, the bind action method, where to go in memory to find the function, where to jump to. Okay, so that's what's going on there, and that's why things that go in permanent storage have a colon operator. The other two types of operator you use are pointers, are arrow operators for pointers, and dots for instances or references. Let's look at some examples starting from the top. So mygrab.grab. Mygrab is an instance there of a grab class or grabber class or something like that, and .grab is a method on it. MyBoolCount.Bools we used earlier in the previous section. That's a struct, and the .bools is an integer member of that struct. Or myGrabRef.grab is very similar to the top line. It's a reference to that method. Okay, and in all those cases, you use a dot, because remember, you use references you treat very much like the object itself. So, how about the arrow operator? Well, we use the arrow operator when we're dealing with a pointer. So, myGrabPointer, we want to access a method called grab or a property called reach. So, the bigger picture, if we zoom out for a moment, is those things that can vary and do vary at runtime, we access using the dot or the arrow operator. And they loosely map over to the stack and the heap over there on the left. So hopefully that gives you a little bit more context as to when to use these different objects. So basically you ask yourself, look, here I am inside my IDE, and it's asking me here, let's say, for a function reference, or it's got this horrible signature, but you find by going and looking at an example code on the web that they're passing in methods. And you see that the pattern is that people are saying ugrabber. Then you ask yourself, well, ugrabber what? Is it arrow? Is it dot? Well, these don't work because we know the location of ugrabber grab now at compile time. So you're using this static accessor, this colon colon. And then, of course, we need to find the address of that. So that's how that whole line comes about. So hopefully that's clearer for you. Do refer back to this slide as and when you need to. And I hope that makes things clearer. So over to you. I want you to create a release method. Follow the example of the grab binding. The enum for release is IE_released. Log that the key has been released when you let go of the grab key, and test, and if it works, jump with joy. So go ahead, pause the video and do that now. Welcome back. So very much by analogy to what we've done before, let's start in the header file and let's make ourselves a release method. So I don't need to, no, just start from scratch. Called when grab key is released. I won't say key when grab is released. Okay, and then it's just void. We don't need anything coming back right now. Release. Great, so now let's go implement that. Let's make the method first, void, ugrabber, the class name, release. And again, you see how we're using this static accessor thing here. This is saying we already know about ugrabber at compile time, so we can go colon colon release. And then I'm going to do a log that is almost identical. Simple. Now, how do we do the binding? Well, the binding is very, very much by analogy to what we have before. Nothing wrong with cutting and pasting code, actually saves errors. Question, is it grab? Is the action still grab? Yes, it is actually, because it is the fact that the grab key is released. So we only have a single action here, which is grab. We press the key, we release the key. We operate on the same object, i.e. the grabber, and this time we call release. This is the fully qualified method name, i.e. this guy here, and the ampersand tells us the address of. Wicked. Let's go and try it and see how it works for us. So, build. While it's building, I actually haven't got my project open right now, so I'll open the project. And I will hope that it builds properly. Unreal's pretty good at handling this. There's things compiling, and yet Unreal's in the middle of opening. It seems to handle all this okay. These kind of weird, like, build over here while this opens, and yet there's still, might notice there's been a hot reload come up, i.e. that the build is finished. It kind of depends when Unreal opens. It's started to pick up, I think, the fact that the render's going, the compile's going on in the background. But in this instance, I'm going to have to see in the IDE whether it's finished because Unreal hasn't fully hooked in. Okay, let's take a look. Push the left key, grab pressed, release, grab released. Not getting the released. So what's wrong? I'm going to try hitting compile in Unreal. It may simply be that I opened it while it was still compiling. Let's see. Nope. So it's not working. Let's go back to the code and see what's wrong. My enumerator looks okay because it's subtle, but you can see that it is actually returning a number, 1 for that, 0 for that. Release is the right name. The log is different. Okay, I'm going to recompile. So this is an interesting test case of what do you do if you think your code should be working and you suspect that it's not you, it's just that the system is not working? Well, let's see what we can do. Grab press, still not working. So at this stage I'll be closing and reopening Unreal, and if that doesn't work, we can do the clean that I showed you a couple of videos ago. There you go, it's working now. So what I said about it not being a problem to open Unreal during the compilation, it kind of turns out in this case it was a problem. So you are safer not opening the engine in the middle of a compilation because it looks like in some cases it can go wrong. So press and release is working both on the left shift and the right mouse button, and we are good to go. So congratulations on that. Remember the diagram, remember it's in your slides. I hope that it's useful to you, this memory diagram here, and I'll see you in the next video.